Hello, everyone. So today we're going to be continuing yesterday's discussion and seeing an application of least common multiple. Remember, our objective here over the coming days and weeks is going to be converting more complicated expressions into something simpler so that we can ultimately solve equations that otherwise we wouldn't be able to do. So let's take a look at this right here. You remember when we first started visiting fractions, when we did things like multiplying and dividing? Let's say we had something like this. Let's say I have 7 over 9 times 3 over 2, or something like this. This is going to be pretty straightforward, that all I do here, since I'm multiplying, is I multiply my numerators and I multiply my denominators. 7 times 3 is 21, 9 times 2 is 18. Both of these numbers here are divisible by 3. 21 divided by 3 is 7. 18 divided by 3 is 6. So my answer would be 7/6. This is pretty straightforward because we're doing multiplication, and ultimately when we take a fraction, we're doing division. Division is, of course, just the inverse of multiplication. So the question becomes a little more complicated. Let's take a look at the same example, 7/9. And this time, let's say plus 3/2 right here. And I want to know what that equals right there. So why is ultimately this a little bit more complicated? Well, I'm dealing with 7/9 and 3/2. How am I supposed to add those two things together? Whenever they're not on the same terms, this becomes a little bit more difficult. For example, even when I'm adding up, say, money, for example, if I have dollars, quarters, nickels, dimes, just all kinds of different things, what is it that I do? I always get the same terms together. That is, I get all my $1 bills together, I get all my quarters together, I get all my nickels together, I get all my pennies together. The reason is because when I have them there in the same terms, it's so much easier to add things together than if I try to just pick them at random and count them all at the same time. So I need to apply the same logic here. I need to make these on the same terms. I need to think of this in terms of ninths, halves, or something that they have in common. Maybe I can't convert halves to ninths very easily, or ninths to halves, but maybe I could convert them both to something a little bit easier to work with. How am I going to do something like that? What I need ultimately to find is the greatest common denominator in both of these cases, and I'm going to leave both the numerator and the denominator blank. This is what we call the least common denominator. That the least common denominator is simply the least common multiple of the two denominators. It's the least common multiple of the two denominators. Remember, the denominator is the number on the bottom of the fraction. So I need the least common multiple of 9 and 2. 2, of course, is just 1 times 2. 9 is 3 times 3. So I have a 3 here. I take the higher power, which is 3 squared. I have a 1 and I have a 2. I don't need to worry about the 1, so I'll just write the 2. 3 squared is 9. 9 times 2 is 18. I can pretty much see that just by looking at them. I could multiply the 2 and get immediately 18. So the least common multiple is 18. So in other words, what I need to be doing here is thinking of both of these fractions in terms of 18ths rather than ninths or halves. How many 18ths is 7/9? Well, what do I have to do to get from 9 to 18? I multiply by 2. So if I'm going to multiply that number by 2 to get 18, I must do the same up here to the numerator. So 2 times 7 would be 14. So in other words, I can think of 7/9 as 14/18. What do I do to go from 2 to 18? I have to multiply by 9, but I must do the same thing to this 3. 9 times 3 is 27. So I have 27/18 plus 14/18, and now I'm thinking solely in terms of 18ths. I have 14 of them and 27 of them. 14 plus, say, 30 would be a nice round even 44. Backing off the extra 3 I added would be 41. So I have 41/18. If I wanted to, I could convert this into a mixed number, in which case 18 goes into 41 2 whole times. 2 times 18 is 36. I would have a remainder of 5 in that situation and leave the remainder in terms of 18ths. Either one of these formats is going to be acceptable to me. But this is the logic of what we're doing here. We need to get these on the same terms in order to work with them. Now let's take a look at an example a little bit more like what we're doing right now. Let's say I have 5 over 3x plus 9 over 4x. What would this be the same thing as? Remember, equality means the same thing. I want to know what would this be the same thing as, because thinking of it in terms like this isn't really useful to me. This is complicated. I don't like using complicated things. I want to make it more simple and straightforward. So I need the least common denominator here to get them on the same terms. That means I need the least common multiple of 3x and 4x. So I'm going to take these individually, least common multiple of 3 and 4, and of the x and x. In the case of x and x, that's easy. Least common multiple is just x. And in the case of the least common multiple of 3 and 4, the answer there is going to be to just take 3 times 4, which is going to be 12. That's the least common multiple of the two right there. So when I have 12 times my x, that tells me that my least common denominator is going to be 12x. So all I've done is I've taken the least common multiple of these two denominators. The least common multiple is going to be 12x. So what do I need to do to get from 3x to 12x? All I do is multiply by 4. But I must do the same thing to the numerator, and 4 times 5 is 20. So 5 over 3x could be thought of as 20 over 12x. Those are the same thing. How do I get from 4x to 12x? I would just multiply by 3, and 3 times that 9 is 27. So I have 20 of them, and 27 more of them means I have 47 of them. So this would be our answer, and where we're going with this is when we see an expression like this, we could ultimately think of this more complicated expression as this much more simple and straightforward one. For example, what if I were to give you a full equation and I told you 5 over 3x plus 9 over 4x is equal to 6 or something like that, and I asked you to solve that equation? That is to say, tell me what unknown value would make that statement true. As I've expressed it to you, that would be very difficult to solve, because how am I going to figure out what makes that true? In order to solve it, I need to make this simpler to work with. And I realize, well, this question is logically equivalent to me asking you this question. That's a lot more straightforward to work. There's still a few steps involved, but this is a lot easier to solve than this one is. So that's the benefit behind this methodology. Let's take a look at a few more examples here. Let's say I have x plus 3 over x minus 7 plus x minus 2 over x minus 1. How am I going to simplify something like this? I need the least common multiple of these two denominators so I can put these on the same terms. Now here, remember, whenever we're looking for least common denominator, what do we do? We take the factors of these things. Now in this case, these have no factors other than 1 in themselves. They can't be reduced any further. So all we're going to be able to do is multiply the two to get their least common denominator. Their least common denominator is just going to be this times this. That's the least common multiple of the two things, is x minus 7 times x minus 1, because they have no factors other than 1 in themselves. So I'm going to need to get this in terms of x minus 7 times x minus 1. Try saying that several times fast. Remember, that's the meaning of a fraction. So how am I going to get this fraction here into the same denominator here? What did I have to do to x minus 7 to get to x minus 7 times x minus 1? I just multiplied times this term. But if I multiply the denominator times that term, I must also multiply this one times that same term. So my numerator is going to be x plus 3 times x minus 1. I'll go ahead and carry my plus sign. For my second fraction, once again, I want my common denominator. So what am I going to have to do to get this into this? I'm just going to multiply it times x minus 7. But if I do that to this, I must do the same here. So I have x minus 2 times x minus 7. That's going to get me what I need. So now I can combine both of these now that they're on the same terms. So I have this plus this right here. I have x plus 3 times x minus 1 plus x minus 2 times x minus 7. Now if I wanted, I could FOIL these things and try to somehow make it a little bit easier to work with, but ultimately this is just how we're going to combine them at this point. There's really not any great need to FOIL this and end up with terms of x squareds and whatnot, but it's not so apparent in this example because of the way we've set it up, but the benefit to this methodology is that very often when we do this, we're going to find, wait, there's something in common to all three of these, and then we can factor it and cancel it out. Let's take a look at another example right here. Let's say I wanted to combine 5 over 6x minus 2 over 3x squared. How am I going to combine these two right here? I need a common denominator here, so I need the least common multiple of these. The least common multiple of 6 and 3 is 6, and the least common multiple of x and x squared is x squared. So for my first fraction, what do I have to do to multiply this in order to get this? I just need to multiply times x in that case. But if I multiply this times x, I must also multiply my 5 times x. For my second fraction, what do I need to multiply this by to get 6x squared? I just need to multiply times 2. But that means I also must multiply this by 2, which means I get 4. So I'll go ahead and write my fraction there, and then I can combine these two and get my answer right there. So have a look at these, practice with them, and remember this is an application of least common multiple. What we're looking for is the least common multiple of two denominators. This is exactly the methodology we take whenever we have fractions that are not on the same terms. We need the least common multiple of those two numbers so we can put them on the same terms and then make them easier to work with.